let's suppose, so this is the variable, okay, variable name, something called, okay, you can take any variable name, right? Okay, let's just I'm taking name, okay, so this is what variable name, guys. Let me write variable name, right? For this variable name, okay, so we have to assign the data, right? So in Java, how many types of literals we can assign? I mean, either integer values we can assign, right? Either 10, okay, like that. Integer values means already we know, right? Byte short, byte short, int long, okay? Either integer values we can, or else floating point, okay, like that. Floating point values also we can assign, or Boolean values also we can assign, right?
Character.
Or else char values also we can assign, or come on, string, right? String values also some assign, right? Okay, so only these are the data, right? We can assign. Other than that, cannot assign anything else, right? So already we completely understand what is the integral literals, what is the floating point literals, what are the Boolean literals, right? What is the char literal? So we completely understand, right? So do you have any questions, guys, on that?
No,
Right?
sir.
So what else now? String literal, right? So we will see string literal, guys. We will see string literal now. String literal. Okay. String literal. What is the string, guys? What is the string? Come on, tell me, what is the string?
Sequence of characters.
Set of characters.
A sequence of characters within within double quotes, right?
Yeah, double.
Within double quotes is called string literal. Okay, a sequence of characters within double quote is called, okay, string literal. What is the example? We need to open double quote. A sequence of character A, B, C, D, F, G, like that. Okay, so this is what string, a sequence of characters, right? Okay, so this is called what? String, guys. String representation, string literal representation. Okay, so what is the example? Let me take. So to represent, okay, to hold the string values. So what is the variable type we have to take to hold the string literal? So which type of variable we have to take? Come on, which type of variable we have to take?
String variable.
String.
String type only, right? Okay, something course. Course is what here?
Variable name.
Variable name. So which course you guys are studying? Java.
Java.
Okay. See here, Java is what? Sequence of characters within double quotes. That is called what? String literal. Okay. To represent string literal, so what kind of data types we have to use? I mean that variable type, it should be string. Understand? Guys, come on. Okay. So now, okay, so this is called string literal, guys. Okay, so no need to explain much on this, right? The sequence of characters, that is called string literal. So to hold the string literal, what kind of data type we have to use? String data type we have to use. Okay, so that's it. Okay, so now understood, right, Shravani? Okay, so now, so we complete all the literals, guys. But actually, at 1.7 version, we have few enhancements in literal, guys. So what are the 1.7 enhancements, you know? Okay, in 1.7, in 1.7 version of Java, okay, we have, few enhancements. enhancements in literals. In which type of literals? In integer literals, guys. Okay. So what are those? Okay, integral literals. Integral. Integral. What are those, you know? The first one is binary literal. Binary literals. Okay. What is the binary literals? So, how many types of integral literals we have, guys? Come on. How many types of integral literals we have?
Three.
Three. What are those? Come on, fast, guys.
Decimal, octal, hexadecimal.
So, until 1.6, right? Until 1.6, okay, we have three types of integral literals,
Integral
right?
literals.
Okay. So, what are those? Decimal
Octal,
Octal, hexadecimal.
hexadecimal.
and hexadecimal, right? Hexadecimal. But now, after 1.7, in 1.7 or after 1.7, we have one more type of, okay, the integral literal added, guys. What is that? Binary literal.
Binary.
Okay, binary literal. So what is the binary literal? Okay. So finally, okay, so if you add anything, so how the data will be stored into the memory, guys? In binary form only, right? Either 0 or 1 only, right? So, but from 1.7 onwards, we can specify literal value even in binary form also, guys. Okay. So how can we specify the binary value, okay, in binary form? So as of now, we are specifying integral literal means decimal form or octal form or hexadecimal form, right? So along with that, so now we can specify even binary form also. Okay. So how to specify binary form? If you want to specify any octal value, how can we define, guys? How can we add?
Starting with 0.
Right. It should be prefixed with 0. Okay. So in order to assign hexadecimal value, so what is the syntax?
Zero, small x or
Yeah, you
zero.
have to prefix
Zero
with
capital
0x. Either small x or capital X. You have to prefix with 0x. Right? In the same way, the literal value, okay, in order to assign the binary form value, okay, binary form value, you need to, okay, you need to prefix with 0b, guys. 0b. Understand? You need to prefix with 0b, either capital B or small b, guys. Okay? Understand, guys? Okay. Allowed digits are, what are the allowed digits, guys? Binary form.
Zero
Allowed
and
digits.
one.
Only
Zero.
0
Zero.
and 1. Okay, binary form means only 0 and 1, right?
Yeah.
Okay. Hope you people know binary form. So if you add anything, okay, in the system, okay, how the data will be stored, guys? Okay, in the form of binary format only, either 0 or 1 format only. Okay. So from 1.7 onwards, we can add binary form also. We can assign binary form values also to the integral data types, guys. Okay. So how can we specify the binary form? You need to prefix with 0b or small b or capital B. Okay. Let's suppose, let me take one example, guys. Example, I'm taking, okay. So int, okay, int, let me take something, guys. Int x, okay, variable name x I'm taking. Here, I want to represent binary form, either 0 or 1, right? So let me keep 1, 1, 1, I'm keeping, guys. Okay, 1, 1, 1, again keeping. Here, how to specify binary form? 0,
B.
B. Okay, then only it will treat it as a binary form. Okay, so now this is the binary form. Okay, if you specify either binary form or decimal form or octal form or hexadecimal form, so finally how it will convert, guys?
Decimal.
Decimal only it will convert. How to convert binary form to decimal, guys? How to convert now? What is the value? If I want to print system.out.println of x, what would be the output here?
15.
15, right? You know, right? 15. Okay.
Yes.
So binary form. Okay. 2 power 0 into 1 plus 2 power 1 into 1 plus 2 power 2 into 1 plus 2 power 3 into 1. Right?
Yes, sir.
Guys, no need to explain. Or you want me to explain? Right. Right. Okay. See, now what is the value? Int x is equal to
0
b
1 1.
111, right? So this is the binary form value. So finally, all this binary form value will be converted into what? Which form? Decimal form. So how to convert? So double one, right? So here, just we have to take, this is the value, right? All four values, right? So four values, how? Let me take. Just I'm taking these four values, guys. Okay, that's it. 1, 2, 3, 4. Okay. So what is the value? 1, 1, 1 we have, right? 1, 1, 4, 5. Okay. So these are the values. Now, how to convert, guys? Binary form, right? Binary form to decimal form. So now this is what? 2. 2 power 0, right? 2 power 0. This one? 2 power?
1.
2 power 1, right? This one? 2 power
2 power
2.
2.
This one? 2
2
power
power 3.
3. Okay. Now calculate. What is the value finally? 2 power 0 means what? 2 power 0.
1. 1.
Next plus 2 power 1 means
2.
huh? 2. So 2 into 1 means 2, right? Plus. Next one. 2 power 2 means 4.
4.
4 into 1 means 4, right? Next. 2 power 3 means what? 8. 8 into 1 means 8. So what is the value finally? 15. Okay. So that is the value we will get, guys, finally here. Output. Okay. Hope you guys understood. Okay. So now, what is the other one we have? Okay. Usage of underscore symbol in numeric literals, guys. Usage of, okay, underscore symbol. Underscore symbol in numeric letters. Okay. That is the first enhancement. Okay. Binary form. That is completed. You guys understood, right? Binary form. So now we will see the other one. What is the other one, guys? Okay. Usage of underscore symbol in numeric form. So from 1.7 onwards, we can use underscore symbol in numeric literals, guys. Understand? So let's suppose as of now, let me take example. Okay. Let me take int. Okay. Int x is equal to, I'm taking, okay, guys. How to spell, guys? Tell me. What is the value? This one? What is the value? I mean, just what I'm expecting here, just tell the number, okay, in mathematics.
10111010.
Not like that. Calculate money. So 10 lakhs, 1 crore, 10 crore, like that we will tell, right? I'm expecting that way. Tell me. Hmm?
1 crore, 1 lakh.
1 crore.
Tell me now. Tell me now. 10 crore, 11 lakhs, 1,011 rupees, right? I'm asking in the rupees form, guys.
Yes, sir.
10 crore,
Yes, sir.
11 lakhs, 1,011 rupees. See, the readability, okay. I mean, so if you have number like this, okay, so there is a problem, right? So the readability will be down, guys, will be decreasing. The readability of the, okay, this variable will be decreasing, right? So in order to fix, if you add like this, comma, okay, you can easily understand, right? Understand?
Yes,
So
sir.
10 crore, 11 lakhs. Okay. So this is the 1,000. This is 100 form. This is one form. 100 form, 1,000 form, lakhs form, or okay, crores form. So like that, if you divide, then we can easily read that value, right? So in the same way, okay, people introduce in 1.7 underscore, guys. Okay, underscore. People introduce, guys, in Java. Understand, guys? So like that. So this one also, okay, valid, guys. After 1.7. Understand? So underscore symbol also we can add, okay, in the numeric form, numeric literals, guys. Understand or not? Okay. Let me take double value. Double y is equal to, I'm taking 1, 2, 3, 4, 5, okay, something like taking 7, 8, 9, guys. Right? So now, okay, further we can add like this also. Double y equals to 1 underscore, okay, 2, 3 underscore 4, 5, 6, okay, 4, 5, 6 dot, okay, here what 7, 8, 9, right? 7 underscore 8 underscore 9. So like that also you can add, guys. So underscore also will allow. Okay, for what? Integral literals. Understand? Everyone?
Yes, sir.
Okay. So here there is a limitation, guys. Underscore symbol we can use only between digits, guys. Okay. Underscore symbol we can use only between digits. Okay. If you use anywhere else, we will get compile time error. Let's suppose I'm taking double y, same thing. Okay. Just I'm putting underscore here. I'm putting underscore here. 1, 2, 3. Okay. Underscore 4, 5, 6. Underscore dot. Okay. 7. Underscore 8. Underscore 9. Underscore. Like that. If I give the integral literal value, is it valid or invalid? I mean, valid means it's having any issue here. We're getting compiled time error. Why? We are using underscore, okay, outside of the digits. What is the point here? We need to use underscore symbol only between the digits. Here, see, first of all, we are using underscore. There is no other digits right here. We need to use underscore symbol only between the digits, not outside of the digits. Okay, here see, after 6, I'm using underscore. But after that, there is no digit. There is a decimal point, dot. Right? Here also, underscore. Before this underscore, there is no digit. Here after 9, there is underscore. After this underscore, there is no digit. Understand or not? Okay. So we need to use underscore symbol only between the digits.
Between the digits.
Or else we will get compile time error. Understand? Everyone.
Yes, sir.
So what is the main advantage, guys? The main advantage of this one, by using underscore symbol, underscore symbol between the digits, we will achieve readability of the code, guys. Understand, guys? Readability of the code. Okay. But here we are using underscore, right? Okay. At the compilation, okay. At the time of compilation, these underscore symbols will be removed automatically, guys. Okay. So we are adding these underscore symbols, right? At the compile time, after compilation, okay, these underscore symbols will be removed automatically. So for JVM, okay, so what is the value go for JVM, you know? So the without, if you remove the underscore, what is the value here? 1, 2, 3, 4, 5, 6.789, right? So this is the value only will come to JVM finally, guys. Finally, this is the value will come to JVM after removing these underscores. Understand? Hello. So just okay, for
Yes, sir.
readability of the code only, we are adding these underscores. But at compile time only, after compilation successful, these underscores will be removed. Okay. These underscores values will not be there in .class file, guys. Understand?
Sir.
JVM. So which one we have to hand out to JVM? .class file only, right? Finally, we will hand out .class file to JVM, right?
Yes, sir.
I think already we discussed. No need to discuss on that. If you spent a lot of time on it. Okay.
So then the
So
output will be without the underscore, sir. If you perform any operations using this X and Y, then at the output screen we will did not get the underscore, no, sir.
yes. You will not see the any underscores.
Okay, sir.
Okay. Understood, right, everyone? So these are the new features introduced in 1.7 version, guys. Okay, as part of integral literal. Hope you guys are understood, right? Any doubts here? Okay. Now, okay. So we completely completed all the data types, guys. All the data types and literals, right? So now let me draw some diagram, guys, here. Okay. So what are the data types, guys, we have learned so far? Byte, right? Come on, byte.
Start.
Okay. Byte.
Start.
Short.
In.
Okay. And now here, char. Let me draw one diagram, guys. Okay. Now, okay. Int. Int, what is that? Long. Okay. After long, we have float. Okay. What is the form here? By default, we are choosing. Why it is changing automatically? Okay, float, right? So after float, Arial black, I'm choosing 12. Why guys? Automatically it is going to here. Okay. Okay, guys, float, right? FLOAT, float. So after that, what we have? Finally, double, right? DOUBLE, double. Okay. So byte, short, char, int, long, float, double, right? Hello. 1, 2, 3, 4, 5, 6, 7. Okay, these are the what integral types, right?
Yeah.
Okay. So here, if you see, yeah. Okay. So just tell me, guys. So what is the byte range, guys? What is the byte range? 1 byte, right? Just I'm asking, guys. What is the byte range? 1. Come on, guys. 1 byte, right? What are the short range, guys? 2 bytes, right?
Right.
Array, come on, guys. What is the char? 2 bytes.
2 bytes.
What is the int range? Int
4
size?
bytes.
Huh?
4
4 bytes.
bytes.
4 bytes, right? What is the long size? Size?
8 bytes.
8 bytes, right? What is the float?
4
Float
bytes.
size?
4 bytes.
4 bytes. What is the double, guys?
8 bytes.
8 bytes. Right? See now. Okay. So this is what, okay, automatically promotion, guys, from one type to another type. Okay, assignments. So here you see, so the lower data type values, listen carefully. Okay. So, okay, this diagram we will see throughout entire our class, guys. Okay, you have to remember this diagram. Byte, short, char, int, long, float, double. Okay. So here, the lower type, okay, lower data type values, the lower data type values, we can happily assign to higher data type variable. What I'm saying? We can assign, we can assign lower data type values to higher, higher data type variable. What you understand, guys? What you understand? Okay, so we can assign lower data type values to higher data type variable. So example, if I take, okay, see here, byte b equals to 10 I am taking. Is it valid or not? Hello? Come on, guys. Byte b is equal to 10. Is it valid or invalid?
Valid.
Valid. Hello, guys. Unmute yourself and tell me. So already you completed, right, this course? Where you keep quite calm? Byte b is equal to 10. Is it valid or not?
Yes,
Valid.
sir.
Valid. Now I'm taking int, okay, int x is equal to, I'm taking this, I'm assigning this b. Now b holds what value? B holds what
10.
value?
10.
10 value. Okay. But now I'm assigning that byte value, okay, 10 value to int. Is it valid or invalid?
Valid.
Valid. Okay, int x is
Valid.
equal to 10. Otherwise, you can put like here also, or else you can put int x is equal to 10. The same 10 value I'm assigning to int, right? 10 means what? Within the, what is the range of, 10 value comes under byte range, right? By what is the byte range? 127 to minus 128, right? 10 means what?
Minus
Comes under 128 to 127. So that's why the 10 value internally represents byte value, but directly we can assign to int. Okay, byte is what? Lower data type. Int is what? Higher data type. Here see, what is the byte range? 1 byte. What is the short range? 2 bytes.
2 bytes.
What is the int range? 4 bytes.
4 bytes.
So comparatively, byte is lower data type, right? Comparatively int.
Yes.
Understand or not? So
Yeah.
what is the statement I here? What is what is our statement? We can assign lower data type value to higher data type variable. So that's what we are doing right here. What is the lower data type here? 10 means byte data type value. So we are happily assigning this byte value to higher data type variable. Here x is what? Which type it is?
10.
Int type.
Int type.
Here b is what? Which type it is? Byte type.
Byte type.
Okay. Byte is lower data type, right? Comparatively int. Byte
Yeah.
having 1 byte, int having 4 bytes.
4 bytes.
Understand or not? So just I went to department store, guys. Okay. Hello. Just I purchased 2 kg rice. I just purchased 2 kg, right? 1 kg rice. Let's take 1 kg rice I purchased. But I'm carrying, okay, 4 kg bag, guys. 4 kg bag. So I can happily put 1 kg rice into 4 kg bag, right?
Yeah.
Understand or not?
Yeah.
Okay. So that's what here. Just apply that rule to here also. Okay. So here what? Byte. Byte means what? 1 byte only, the size. Here int means what? 4 bytes.
4 bytes.
Okay. Here which one is the lower data type? Byte. Which one is the higher data type? Int. Okay. So that's why I can happily assign the byte lower data type value. What is the lower data type value here? 10. This is the value, right? Lower data type variable value. What is here? 10.
10.
I can happily assign lower data type value to higher data type variable. Here, what is the higher data type variable? X. X is what? Int data type. Comparatively int is higher data type, right? Comparatively byte, int is higher data type, right? So I can happily assign. Hope you guys are understood. Hello.
Yeah.
Right? So now sort also. Sort 2 bytes. So sort data type value, I can happily assign to what? Int data type. Understand?
Yeah.
I can happily assign to what? Long type. I can happily assign to what? Float data type. I can happily assign to what? Double data type. Understand?
Yes, understood.
Okay. Just see this diagram, guys. Okay. So you may get some doubt. Okay. I will clarify. Okay. So by seeing this, you may get some doubt. We'll clarify. Don't worry. Okay. Here what? See the size, guys. 1 byte, 2 bytes, 2 bytes, 4 bytes, 8 bytes, 4 bytes, 8 bytes. Right? So based on the size, how can we tell which one is the higher data type, which one is the lower data type? Based on the size. Based on the size only we are telling, right? Which one is the lower data type, which one is the higher data type? How can we tell? Based on the size. Here byte means 1 byte, short is 2 bytes, int is 4 bytes. So comparatively these 2 bytes, int is higher data type. Comparatively int, long is higher data type. Why? Long having 8 bytes. Okay. But here float 4 bytes. Double 8 bytes. So here what I'm saying, okay, let me take some value. Int x is equal to, I'm taking something, okay, 1548 value I'm taking, guys. Okay. This is what, guys? Integer value. Now I can long, okay, L equals to long L equals to, I'm assigning this X. Is it valid or not?
Valid.
Valid or not?
Valid.
Valid. Okay. So now, int X is equal to 1548. What type it is, guys? Please unmute yourself. Everyone tell me, follow me. Int X is equal to 1548. So which type of value it is? Come on. Int value. So what I'm trying to do here, I'm assigning int value to long type. So is it valid or invalid?
Valid.
Yes, sir.
Why it is valid?
Lower data type int stored in higher.
So here int data type means what is the size 4. Here long is means what? 8 bytes. So I'm assigning lower data type value to higher data type variable. So that's why we can happily assign. Right? We can happily assign. That's what it is a valid. It is a valid. Okay. Now you might get some question, guys, here. Let me add some more. Okay. Let me add some more. Now here I have long L is equal to something. I have my phone number. Okay. 9876543210. It's not my phone number, guys. Okay. Long L is equal to, I'm representing one phone number. Okay. Now I'm assigning float. Okay. Float F is equal to same value I'm assigning, guys. 98765. Let me assign L. Is it valid or invalid?
Invalid.
Invalid.
Why it is invalid?
Long is 8-bit and float is 4-bit.
4
Right?
bytes.
Okay. So that's why. So by seeing this diagram, yes, you are saying, right, it is invalid. Yes, absolutely correct. But here, if you see the diagram, so what I'm putting here, 4 bytes. Okay, after int long, after long float, after float double. So this is the hierarchy we are putting, right? Okay.
Yeah.
Let me add this, what is called, like this, guys. Okay. If I add arrow, you will have better understanding. Okay, this is the arrow. Means what? These are small. Okay, these are small data types. These are capital data types. I mean, big data types, right? So here it's happily valid, guys. Float F is equal to L also valid. Why it is valid? You know, actually, let me write. Up to these what? So can we do this? Just I want to draw some curve, guys, here. Okay. I don't know how to do. Oh. Okay. Fine, right? So these are what, guys? Height, short, char, int, long. These are what? Integral. Okay. Integral data types. Okay. If you see here, this is what, guys? Float and double. Floating point
Data types.
data types. Right? These are what? Floating point data types. Right? Actually, okay. So let me take one example, guys. Okay. So I have one classroom. Okay. In the classroom, I have 100 chairs. Okay. For each chair, okay, only one person at a time can sit, guys. Okay. Only one person at a time can sit. Okay. So means how many chairs I need to keep in first classroom? 100 chairs I need to put. Understand? So 100 people. For 100 people, 100 chairs. Okay. If you take the second room, okay, 100 people, I'm arranging 50 chairs, but in the 50 chairs, happily 100 people are able to sit, guys. So what would be the magic here? how in 50 chairs, 100 people can sit at a time? Come on, guys, tell me. What can be the possible? Come on, guys, what can be the possible? How can sit 100 people in 50 chairs? If chair width is, okay, if chair width is little bit, I mean, comparatively the first class room, okay, if you put the big chairs, like tables or something, okay, the big chairs, then happily 2 people can sit in 1 chair, right? Okay.
Yes.
In the second classroom, the chairs width is little bit big, guys. Okay. Happily 2 people can sit in 1 chair. But in first classroom chairs, okay, only 1 person can sit, guys. Okay. We cannot sit two persons at a time. Only 1 person can sit. Understand? So with the 50 chairs, happily here 100 people can sit. In coming to first class, in the 100 chairs, only 100 people can sit. Understand? So
Yes,
same
sir.
representation. Same 100 people only here also attending. Same 100 people there also attending. But here, what is the difference? Size difference. Here 100 size, here 50 size. But same 100 people, okay, these first class 100 people, we can send them to second class, and these 100 people happily can sit in 50 chairs. Why? The chair width is little bit big compared with the first classroom. Understood or not, everyone?
Yes,
sir.
sir.
In the same way, okay, this is integral data types. These are floating point data types. Okay, integral data types memory representation in the memory. Integral data type value in the memory representation, okay, different from, okay, floating point value representation in memory, guys. Understand? The way of representation in the memory will be different. Okay, so here 8 bytes for integral types almost equal to 4 bytes in floating point data types, guys. Understand, everyone?
Yes, sir.
Okay, so that's why we can happily assign long value to float data type, guys. Float data type variable. Hope you people understood.
Yes, sir.
Ravani, Pavani, everyone understood, right? So the memory representation. So the value finally where we will store, guys, these values, either integral data types or floating point data types, where we will store in the memory, right? Then the memory, the representation of values, integral value representation in the memory, floating point representation in the memory will be different, guys. Same example, okay? You can correlate with that classroom example, guys. Understand? So the long data type we can happily assign to float data type, guys. Okay, float data type variable. Hope you people understood. And you may get one more doubt here. So char. Okay, so here, come on, tell me. So there is one more doubt you may get. What is the other doubt, guys?
Char.
So here char we have. Okay, so char, can we assign char values to byte and sort, guys? Here sort, no, remove byte. Byte means 1 byte. So we cannot assign, right? Only lower data type value we can assign to higher data type value. So byte is what? Lower data type, comparable to char. But if you see here, sort is what? 2 bytes. Char is what? 2 bytes. So what I mean to say here, I'm taking sort. Sort x is equal to 128. I'm taking, guys. Okay, what is the range of sort, guys? What is the range of sort? Tell me.
2 bytes.
I'm not asking size, range.
0 to 65,535.
Short I'm asking, not char.
2 to the power of 5.
Huh? Short range. Minus 2 power
Minus 2 power 15 to
minus 1. What
2
is the
power
value?
So for
I'm asking
minus
value.
32,768 to 32,767.
32,768.
68. Minus.
Right? Okay, 67 plus, right? Positive value I'm taking. 32,767, right? So now Okay. Here, so char. Okay, let me take thought. Okay. Now int y is equal to x. Is it valid or invalid? What I'm doing here? The sort
valid.
data type value I'm assigning to int data type. Guys. Here x holds what value?
Short.
Short.
Sort data type value. Okay. How can we represent this value? By using variable name only, right? So now this hex holds this value. I want to assign this value to another variable. How can I assign? Directly, if I assign this variable name x to y, then automatically I'm assigning this 32,767 value to y variable, right?
Yeah.
Understand or not?
Yes,
Hello?
sir.
Yes, sir.
Yeah. So now here, is it valid or invalid?
Valid.
Valid.
Oh,
Valid.
Valid. Why? Sort having 2 bytes, int having
Indeed,
4
yes.
bytes. So we can happily assign, right? Lower data type value to higher data type value. That's clear. So now what I'm taking here, char. Okay. Char ch is equal to, what is the range, guys? 65,535, right? So now I'm assigning, okay, int, come on, int y is equal to ch. Is it valid or invalid?
Yeah,
Valid.
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 Okay. Why it is a valid? Char type is 2 bytes, int type is 4 bytes.
4 bytes.
So we can happily assign, right? Lower data type value to higher data type variable. Clear, right? Everyone.
Yes, sir.
Like mine. Okay. So we can happily assign, right? So now, if you see, I'm taking short. Okay, I'm taking short. Z is equal to, I'm trying to assign this char. Is it valid or invalid?
Invalid.
Why invalid?
Short range size is
Range.
32.
Huh?
Short size 32, 767.
Short is
Not-
integral, sir.
Hmm?
Short is integral data types.
Integral data type. Int also integral data type only, right? Int
Char
also
has
integral
high
data
range.
type. Huh?
Char having high range than short.
Yeah. See, here, that's what. Here you see, short also having 2 bytes. Char also having 2 bytes.
2 bytes.
2 kg rice, I can put in 2 kg bag, right? Have any issue?
No issue.
No issue, right? So like that, why can't we add char size, char data type value to short data type? Because short also 2 byte size, char also 2 byte size. Both are equal. So why can't we put char data type value to short data type? So this is the reason. Understand? Here, if you see byte short, okay, short byte short byte short is what? Signed literal, signed data type. Understand? Signed data type. Okay, char is what? Unsigned data type.
Unsigned.
Yes, sir.
Hope you understand.
Yes, sir.
Short is what? Signed data type.
Sign it
Char
up.
is what? Unsigned data type.
Unsigned.
In the short, if you take 2 bytes means how many bits, guys? 16 bits. Out of 16 bit, first bit will go for what? First bit will go for what?
Yeah.
Huh?
Sign.
Signed or unsigned?
Signed.
For signing purpose. MSB, most significant bit. Remember, guys, we discussed, right, everything. We spent a lot of time over there. You should not forget. Okay? Out of 16 bit, first bit will go for signing, either positive or minus, right? Remaining how many bits we have? 15 bits. Only those 15 bits only the data will be stored. Okay. So that's what is the maximum range? 2 power 15 minus. Plus positive values 2 power 15 minus 1. Understand? I think already we discussed it. Okay. Positive values directly will store in memory. Okay. Negative values will be represented in 2's complement. I think already we see, right? No need to discuss on that. Okay. So that's why, what is the range of that due to this signing values? Okay. Due to the signing data types, short value range is 32,767. Char value range is what? 2 bytes means what? 16 bits. Here there is no sign. For character, there is no sign. Right? So here we completely utilize 16 bits. Okay? 16 bits. So that's why here we what is the value? 65,535. Okay. So we cannot assign char to short, right? Why? Char range is 65,535. But what is the short range? 32,767. Hello?
Yeah.
How can we assign? We cannot assign. Understand?
Yeah.
Okay. If size is also same, but if you compare both short and char, short are signed data type, char is not a signed data type. Okay. Short range is 32,767. Char range is 65,535. How can we assign, okay, the smart range value to, the what we call large range values to small range data type? We cannot assign. Understand, everyone?
Yeah.
Okay. So that's why byte short value we can assign to int. Char value we can assign to int. Okay. Int values we can assign to long. Long values we can assign to float. Float values we can assign to double. Hope you people understand. Let me open Eclipse IDE. Okay. Eclipse IDE. Create one more project. Create one more project. Java project. What is the project name? Project name. What we will put? String literal. Char literal demo. Let me put string lit demo. Okay. Something called. Next. Finish. String lit demo. Here I'm adding new class. What is the class name? String literal demo I'm adding. That is the class name. I want public static void main also, and I'm clicking finish. Okay. Right. So what we discussed, guys, today? Please string literal. String. What is the string? String means, come on.
Sequence of character with double
Sequence of characters. Right. Sequence of characters.
Characters.
Okay. So Vignesh, I'm adding. Is it valid, right? See, there is no compile time error. If you want to print sysout control space, we can happily print here name. Okay. We'll get output. Run as Java application. We'll see Vignesh as an output. Understand, everyone? So that is what
Yes,
string literal. So we discussed one more. What is that? Binary form, right? For integral type. So we can assign one more integral type binary form. Binary form value we can assign to integral type, right? What is that? Int something. Okay, let me take int x. Okay, int x is equal to, how can we represent binary form? 0b
prefix 0b
0b
1, right? By saying it cannot be resolved as a variable. Right?
So you kept
in
two,
place
sir.
of 0 we kept was.
Okay. Right. Sorry.
0b.
Okay, guys. Okay, 0b 11, right? Now, if I put this out, okay, control space. So just I want to print X value here. Okay. What is the output we have to see, guys, here? Run as Java application. 15, right? So that's what we seen, right?
Yes, sir.
Okay. So even the underscores also we can add. Okay. Let me add double. Okay. Double D equals to. Okay. I'm adding 1, 2, 3. Okay. 1, 2, 3, 4, 5, 6. Okay. Dot. 7, 8, 9. I'm adding, guys. Yeah. This is what double value. Sys out. Control space. Okay. I want to print D here. We'll get double value, right? The same value you can see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. But now here I'm adding something called underscore. Okay. After 2, 3, I'm adding one more underscore. Here I'm adding 7 underscore 8 underscore 9, like that I'm adding. Now I'm trying to print D. So what is the value you will see finally? What is the value you will see finally? The same value 1, 2, 3, 4, 5, 6.789. Why? This underscore will be removed at the part of compile time only. Understand?
Yes, sir.
Okay. So if I put underscore before 1, okay, or else if I put before decimal dot, see the compile time error, right? Syntax error. Understand? We discussed,
Yes, sir.
right? We need to keep underscore what between the digits only. We cannot keep anywhere else, right? That's why
Yeah, okay.
we are
Yes, sir.
getting here compile time error. Okay, understood, guys? Everyone?
Yes,
So,
understood.
what other thing we discussed? The same thing. Here we discussed, right? These values. Okay. Here we discussed, right? Okay.
Yes, sir.
So we can try it. What is that? Byte b equals to 127. Okay. Now int x is equal to b. Int x is equal to b. I can happily assign, right?
Yes, sir.
Sir.
Already int x defined.
Already down X.
Y. Int y is equal to b. Okay. See, I don't have any compile time errors. Okay. Y byte is lower data type, comparably int. Understand? So now
Yeah, yes.
short. Okay. So let's suppose take long value. Long L equals to, okay, 9876543210. This is the what? Long value. Okay. Right? We need to suffix with either capital or small l, right?
Yes.
Now I'm taking float f is equal to, I'm assigning L. See, I can happily assign long value to float. But here long having 8 byte, but even float having how many byte? 4 bytes.
4 bytes.
But still I can assign. Why? Already we discussed, right?
Yeah.
That the memory representation both are
Yes,
same. Okay. So that's why we can assign. Now let me take short. Let me take char value. Char ch is equal to, okay, 97 I'm taking. Okay. Now I'm taking short. Okay, sh is equal to, I'm trying to assign ch here. See, compile time error. Why? We cannot assign char data type value to short data type. Already we discussed. Even though both are having two size, both are having
2 bytes.
2 byte size. Even though we cannot assign. Why? Char is unsigned data type, short is signed data type. Due to the range of char is, okay, the range of char is more larger than short data type range. So that's why we cannot assign. Okay, we can assign happily to int data type. See, if I put int, okay, there is no compile time error. Compile time error gone. Understand? Everyone.
Yes, sir.
Why? Int is 4 bytes. Char is what? 2 bytes. You can happily assign, right? The range also comparable to char, int having more range. Okay.